Today we're diving into a question that is both deeply personal and incredibly scientific. What is really going on with egg quality after the age of 40? We're going to go way beyond the headlines and get right into the fascinating cellular science behind it all. You know, it's one of those big questions in reproductive health, right? We've all seen the charts, we've heard the numbers, but what's really going on deep down at the cellular level that causes such a dramatic shift?
So the easy answer, the one we all hear, is just age, right? You get older, so your eggs get older, end of story. But, it turns out that's just scratching the surface of a much more interesting story.
The real story, the thing that changes everything, isn't just about the passage of time. It's about energy. Yeah, cellular energy. And once you start looking at it that way, the whole picture starts to make a lot more sense. So to really get this energy story, we have to talk about the main character, the mitochondria. You probably remember them from high school biology, the powerhouse of the cell. Well, for an egg, that's not just a cute nickname. It's everything.
And just to give you a sense of scale here, a single egg cell has more than 100,000 mitochondria packed inside. That's just a mind-blowing number. It's way more than pretty much any other cell in your body. And believe me, there's a really, really good reason for that.
So why all that power? Well, an egg has some of the toughest, most energy-hungry jobs in our entire biology. Think about it. First, it has to perfectly, and I mean perfectly, separate all of its chromosomes. Then, it needs this huge surge of energy for fertilization to even happen. And after that, it's on its own, fueling all the cell division to create an early embryo. All of these jobs demand a massive amount of cellular fuel, which is a little molecule called ATP.
Okay, so what happens when these little powerhouses start to fail? What happens when these cellular batteries just can't hold a charge like they used to? This is where we get to the real biological reason for declining egg quality.
Okay, so here's a key difference. The main DNA in our cells, the stuff in the nucleus, it's like a fortress with an amazing repair crew. But the DNA inside our mitochondria, it's kind of left to fend for itself. It has very few repair tools. So over time, all the little bits of damage from stress and just life, they just start to pile up year after year.
And that accumulated damage sets off this cascade of failure. It's like a series of dominoes. It all starts with age and stress, right? That leads to mitochondrial damage. That damage means less ATP, less energy. And when there's not enough energy, the super delicate machinery that's supposed to pull chromosomes apart gets wobbly. It starts making mistakes. And those mistakes are chromosome errors. So that last domino, the chromosome errors, there's a scientific term for that, Aneuploidy. All it means is that an embryo ends up with the wrong number of chromosomes, either too many or too few. And this, right here, is the #1 biological reason for things like implantation failure and early miscarriage.
And wow, this chart, it really shows you what's happening. The risk of aneuploidy doesn't just go up a little bit, it skyrockets. Look, at age 35, it's around 35%. But by 40, it's suddenly the majority, like 60%. And by 45, we're talking 80 to 90%. It's a steep, steep curve. And what's fascinating is that this trend almost perfectly mirrors the decline in mitochondrial energy production.
So we've got chronological age setting the stage. But it turns out our modern lifestyles can actually hit the fast-forward button on this whole process. Let's dig into some of those factors that can speed up mitochondrial aging.
This right here is such a key concept. An egg isn't just floating around on its own. It's developing for months inside what's called the ovarian microenvironment, basically the little ecosystem it lives in. So the health of that entire system has a direct impact on the egg's final quality and its energy levels. So what are the things that mess with that environment? Well, scientists have pinpointed 3 big ones. First up is oxidative stress. The best way to think of this is like cellular rust. It's caused by things like environmental toxins or inflammation, and it directly harms the mitochondria. Then you have declining NAD+ levels. NAD+ is a super important molecule for making energy, and things like chronic stress or not getting enough sleep can just drain your levels. And finally, chronic inflammation. This can just throw the whole system out of whack, disrupting the delicate balance needed for a healthy egg to develop.
Okay, I know this can all sound a little heavy, but here's the good news. The science doesn't just stop at the problem. It also points to a really hopeful path forward, and that's where we get to talk about recharging our cellular health. And this is probably the most important takeaway of all. Look, you can't reverse your chronological age, right? You can't turn back the clock. But you can have an impact on the metabolic environment where your eggs are growing. This shifts the focus from something you have no control over, your age, to something you can influence, which is your cellular health.
So how does that even work? Well, it's because an egg doesn't just pop up out of nowhere on ovulation day. It actually goes through this long maturation process. It takes about 90 to 120 days to get ready. And that 3 to 4 month stretch, that's a critical window of opportunity. That's the time when the health of that whole ovarian environment can make a huge difference in the quality of the final egg.
And this is where a ton of the current research is focused. It's all about strategies to improve that environment during that maturation window. Things like supporting the mitochondria directly with nutrients like CoQ10, using precursors to boost NAD+ levels, loading up on antioxidants, and of course, using diet and exercise to improve your overall metabolic health and bring down inflammation.
So if you take away just one thing today, let it be this. The decline in egg quality isn't just about getting older. At its heart, it's a story about an energy crisis. It's about mitochondrial energy failure. When those tiny power plants can't keep up, the whole delicate process of creating a healthy embryo just can't work properly. Which really leaves us with a huge, fascinating question for the future, doesn't it? Is supporting cellular energy the new frontier of fertility? It really feels like we're shifting away from just looking at age and towards something much more dynamic, focusing on energy, on metabolism, and on the health of our mitochondria. It definitely seems like that's where all the science is pointing. Thanks for joining me.